Hi folks, welcome back. So in this session, we're going to look at one of the core important concepts, data gathering. In the forthcoming sessions, we'll look at the core concepts such as the data gathering, data cleaning, data exploration, and data analysis. Now let's see what's in data gathering. So the data can be generated from a wide range of sources. So why do we need to gather the data? We have seen in the previous slides and the previous sessions why a data is important. So the data gathering is the foundational stage of the data analytics process, where data is collected from various sources to form the base for an analysis. So the importance of data gathering. So the data gathering is an essential as it lays the groundwork for all the subsequent stages of the data analytic process. So what is most important here? The quality and relevance of the gathered data directly impacts the accuracy and reliability of the analysis and insights derived from it. What are the different sources of data? So in today's interconnected world, data is generated from multitude of sources, which provides valuable insights for the business and organizations across various industries. I have taken 4 different sources. The first important source is your internal database and system. One of the primary sources of data is internal databases and systems. So these include your customer relationship management, CRM systems, your enterprise resource planning, ERP systems, and transactional databases. And internal databases contain valuable information about customers, sales transactions, inventory levels, and much more. So, analyzing this data can provide insights to customer behavior, sales trends, and operational efficiency. The second important source is the external source. So organizations also gather data from external sources such as public databases, government databases, social media platforms, and third-party data providers. Public database and government datasets offer a wealth of information on demographics, economic indicators, and public health trends. So social media platforms provide invaluable insights into customer sentiment, brand perception, and market trends. The third-party data providers offer specialized data sets on various topics, including market research. So this third-party data providers would have done in market research on their own, and they would sell the data, and they would sell their market research, the customer behavior, and the industry benchmarks to the companies. The third important source is sensors and IoT devices. So with advent of the Internet of Things, IoT, sensors and connected devices have become significant sources of real-time data. These devices collect data on parameters such as temperature, humidity, location, and mission performance. So in manufacturing, IoT sensors monitor equipment health and detect anomalies to prevent downtime and optimize production processes. So in healthcare, let's take wearable devices. Wearable devices track vital signs and patient activity to support remote monitoring and personalized care. And fourth important source that I want to bring up here is the surveys and questionnaires. So the surveys and questionnaires are valuable tools for gathering qualitative and quantitative data from customers, employees, and other stakeholders as well. So organizations use survey to collect feedback, opinions, and preferences, enabling them to understand customer needs, measure satisfaction levels, and identify areas of improvement. Therefore, analyzing the survey data allows organizations to make data-driven decisions, prioritize initiatives, and enhance customer experiences. So, what do we need to understand from this slide? So, data comes from a diverse range of sources, not only from the internal and the external structured and unstructured. By tapping into the sources and harnessing the power of data analytics, any organization can gain an actionable insights and drive innovation and stay ahead of the today's competitive landscape. So, given this, what are the challenges of the data gathering? So, we spoke about what is data gathering, what are the different sources of data gathering, what is the important challenge that we are facing today. So, the data gathering is a crucial step in the data analytics process, but it also comes with a fair share of your challenges. So, what are a few common obstacles organizations face when gathering data for analysis? The first important thing is data quality issues. So, one of the primary challenges of the data gathering is ensuring data quality. So, organizations often encounter issues such as incomplete, inconsistent, and inaccurate data. Okay, the company says, I have a decade old of data. But if you go back to their database and you check, most of this data are incomplete, inconsistent, and inaccurate data. So, what are the implications of the incomplete data? So, this incomplete data may contain missing values or fields, making it challenging to perform meaningful analysis. What about the inconsistent data? Inconsistent data may have discrepancies or errors, leading to unreliable insights. Say, for example, the age of a customer, right? So, if there is a database migration, so the 2K error problem that we have seen, so automatically it was giving 1900, it was giving some random values. So inconsistency in the data is it's very important to be cautious. So, inaccurate data may contain errors or outliers, so skewing analysis results. Therefore, addressing data quality issues requires through data validation and cleansing process to identify and correct these errors, ensuring the accuracy and reliability of data used for analysis. Now, the second important challenge that I would bring up here is the data integration challenge. So, harmonization of data from disparate sources with varying formats and structures. Because the organizations often have data stored in different systems like database or file formats, making it challenging to consolidate and harmonize data for analysis. Data integration involves aligning data from different sources, standardizing formats, resolving schema conflicts, and ensuring data consistency. So, by implementing robust data integration solutions and tools can help streamline the process and facilitate seamless data integration across the organization. The third important point that I want to bring up is the privacy and compliance concerns. So, what is privacy and compliance concerns are critical considerations when gathering data. So, especially in this light of increasing regulations and concerns about the data privacy and security. So, what is that the organizations need to do? So, organizations must adhere to the privacy laws and regulations governing the collection, storage, and use of sensitive and PII, personally identifiable informations. So, collecting and using data ethically and responsibly is paramount to maintaining the trust with customers, stakeholders, and regulatory bodies. So implementing stringent data governance practices, ensuring data encryption and anonymization, and obtaining explicit consent from the individuals are essential steps to mitigate privacy and compliance risks. So what is the takeaway here? So the challenges in data gathering, such as data quality issues, data integration challenges, and privacy concerns, underscore the complexity of the data analytics processes. So addressing these challenges requires a multifaceted approach, including implementing data validation and cleansing procedures, adopting robust data integration solutions, and prioritizing privacy and compliance measures. Therefore, overcoming these obstacles is essential to unlock the full potential of data and derive actionable insights that derive informed decision making in the business success. So what are the best practices of data gathering? So the data gathering is the crucial step. We have seen that. So how can we start with it? The first point here that I want to bring up here is, so define clear objectives and data requirements. So before initiating the data gathering process, it is essential to clear objectives and identify the specific data requirements that align with organization rules. So this involves understanding the purpose of the analysis, defining key performance indicators, KPIs, and identifying the types of data needed to support decision making. By establishing clear objectives and data requirements upfront, organizations can focus their efforts on collecting relevant data that drives actionable insights. The second point here is implementing data governance policies and procedures. Data governance plays a crucial role in ensuring the quality, integrity, and compliance of the data throughout its life cycle. Organizations should implement robust data governance policies and procedures to govern the data gathering process effectively. So data gathering process as such, defining the data standards, establishing the data quality metrics, enforcing data management policies to maintain data integrity and compliance with regulatory requirements. By prioritizing data governance, organizations can mitigate risks associated with poor quality and ensuring the reliability of the analysis of results. The third important point is to leverage advanced technologies and tools for data collection. So the organization can leverage advanced tools and technologies such as data integration platforms, APIs, and data lakes to streamline the data collection process and extract valuable insights from the diverse data sources. Gone are the days that we are going to collect data from various different sources. Now there are integration platforms and data lakes to streamline the entire data collection process. Okay, so therefore, by leveraging these advanced technologies and tools, organizations can enhance the efficiency and scalability of their data gathering efforts. The fourth important point is establishing the data stewardship roles and responsibilities. To oversee the data gathering process, ensuring accountability, organizations should establish data stewardship roles. So, what is a data steward? So the data stewards are responsible for overseeing the data governance initiatives, ensuring the data quality, and facilitating collaboration across departments. So these data stewards play a critical role in defining the data standards, enforcing data policies, and resolving data-related issues. Therefore, by establishing the clear roles and responsibilities for data stewardship, organizations can ensure the data gathering activities are conducted effectively in accordance with established guidelines. So I would like to conclude here. So the effective data gathering is essential for deriving the meaningful insights and making informed decisions based on data. Therefore, by following the best practices, such as defining clear objectives, implementing data governance policies, leveraging advanced technologies, establishing the data stewardship rules, organizations can overcome challenges and maximize the values of their data assets. By prioritizing data gathering and investing in data management initiatives, organizations can unlock the full potential of their data and gain a competitive edge in today's data-driven world. Thank you. Now, so far we have seen what is on Lime, what is on SHAP, what is explainable AI, the importance of explainable AI. Now let's see in quick demo how Lime and SHAP can be used and how efficient they are. Let's take a quick demo. It's this done with a smaller data set with our iris data set. Let's go step by step. From sklearn dot datasets import load iris. Then you load iris inside the object iris. Then you define x is equal to iris dot data, y is equal to iris dot target. X and y are defined. Now the next step is to train test split. We'll use train test split that I have already called in the library from scikit-learn model selection, train test split. I've done the train test split, x comma y comma test size is equal to 0.3 comma random state is equal to 1. So what is in random state? Take a minute, pass, and then answer. So random state is one thing that's in seed state that we set. So whenever I do the train test split, it's a randomized split. So for you and me to have the same train and same test, the samples to be present in the same train and test. So we are going to set and seed random state is equal to 1. So x train comma x test, y train comma y test. So I've defined x train, x test, y train, and y test. I've given the test size as 30%. So 70% of data will be in training, 30% of data will be in testing. So this is obviously, this is customizable. So this is a rule of thumb. You give a 30% or a 20% to do the train test split. Now let's pick a random forest classifier. So we have seen this random forest classifier using the previous algorithms also. So model is equal to random forest classifier, and you do the model dot fit x train comma y train and you run it. So the model is fit, model dot fit is that set. So you fit it and then you use the SHAP to explain the predictions. First I'll do the SHAP and then I'll use the line. So what does SHAP do? Let's take SHAP dot tree explainer and I take the model. Okay, so what's the model? Model is the random forest classifier. So obviously random forest classifier is a black box model because it uses a number of decision trees to build the model. So since this is a black box model, I have taken random forest classifier to use SHAP and line. Let's use explainer SHAP is equal to, and let's also use SHAP values is equal to explainer SHAP dot SHAP values x test. Okay, and you print the SHAP values using x train. Let's check how's the array, and let's print the SHAP values. Print SHAP values 0. Okay, okay, SHAP, it's not in shape. SHAP values 0. So what does it show? It's going to show, So the output, that is given here is calculated for the first instance in your dataset. Let's break it down. So each row in the output corresponds to a feature in your dataset. Each column, each column represents a class or category if you're dealing with classification problems. If you're going to deal with a regression task, there would be typically only one column representing the model's prediction. So the values in the matrix indicate sharp values for each feature in relation to each class or prediction. Okay, so how do you interpret it? So rows, like I mentioned, each rows corresponds to a feature in your data set. Say for example, I'm going to have features like age, income, education. Each row represents sharp values for these features respectively. So the columns, each column corresponds to a class or prediction. Since this is a multi-class classification, each column represents the sharp values for specific class. What happens if it is a regression task? There would be only one column, right? So this is a multi-class classification. We have seen the iris data set. Okay. So, so if it's a regression task, there will be only one column representing the model's prediction. So the values in matrix represents the sharp values for each feature in relation to each class or prediction. So positive values indicate that the corresponding feature value pushes more model's prediction higher, while the negative values like this, right? So the negative values indicate the opposite. Say for example, the sharp value is positive. Okay, is positive. It means that the higher values of this specific is it's tending to increase the model prediction towards a specific class. Conversely, if sharp value is negative, okay, these are negative. Okay, so this is the final predicted class that we have done. This is the predicted class for this. This is the predicted class for this. This is the predicted class for this. Positive it is. It means it is driving higher values for that specific call. Okay. Now, what did we do here? Sharp tree explainer model. So, what is the tree explainer model? Okay, so this line creates a sharp explainer to specifically designed for tree-based models. Okay, so this model is the trained machine learning model for which we want to explain the predictions. The random forest model should be a tree-based model, such as a decision tree, random forest, or a gradient boosting model. If I'm going to use a tree explainer. Okay, so the explainer sharp values. If you ask me what happens if I'm going to use a neural network model, what happens if I'm going to use a different model, there is so much amount of documentation that's available. You can check inside the sharp library. Since this is a short session, so I've taken a random forest classifier and I've shown you the tree explainer. What happens if I'm going to take and sharp values from the explainer sharp? So this explainer sharp method calculates the sharp value for each instance in the XTest dataset based on the model and the explainer object. The resulting sharp values, the variable contains the sharp values calculated for each instance in XTest. These sharp values represents contribution of each feature to model prediction for each instance in the test dataset. So this is what this sharp.tree explainer and the sharp values about the sharp. Okay. Now let's move to lime. So what does a lime do? We have seen a brief introduction and how the calculations are done for lime. I did not get into the complete mathematical calculations. It goes beyond the scope of the session. So I've given you how a lime works and what is a lime, why is it used. Then let's use lime tabular explainer here and extrain. First, let's complete the code and let me explain this piece of code. Classification and feature names. Feature names is equal to iris feature names. Class names is equal to iris target names. Okay. So I've just taken the feature names and the target directly from that data, from the iris data. Okay. Let's use the a lime tabular explainer. Let's store that inside explainer underscore lime is equal to, and also use an lime explanation is equal to explainer lime dot explain instance, and let's take xtest of 0 first instance model dot predict probe. Run this. So what does this piece of line mean? So what do we do here? So I'm going to use a lime tabular explainer. So what is this lime tabular explainer? If you go shift plus tab, you'll get this uh, the help, the hint from the Jupyter notebook. So I'm going to the I'm going to use an prediction. I'm going to explain the predictions of the machine learning models on tabular or unstructured data. That's what a lime tabular data. So I have used the extrain data to train the machine learning model. Lime tabular explainer uses this data set to understand the data distributions and generate explanations. I've given the mode is equal to classification, specifies that the machine learning model is used for the classification task. If the model was trained on regression task, I would have set the mode is equal to regression instead. Like I mentioned, the feature names, iris feature names provides the names of the feature in the dataset. This is optional, obviously, but it helps in displaying the feature names in the explanations. Else it will be a bit confusing. Now the class names, it provides the target names, it provides the names of the target classes in the dataset. This is also optional. Okay, so if you want to display the names in the explanation, you're going to give the class names. It's a good practice to give it, else you will be wondering what is what. Now I've given explainer instance. Lime explanation is equal to explainer underscore lime explain instance. Okay, so this is x for this specific data. The first instance x underscore 0 is the instance for which we want to explain the model's prediction. This could be any simple, any one sample from the test data set. I've taken the first sample, the lime tabular explainer, to generate the local surrogate models for explaining the purposes. It's a surrogate model. I'm going to use different models for explanation purpose. So that's what we have done here. Now let's go one step further and let's print it. Now, so one more thing which I forgot to mention here is it computes the explanation of the specified instance using a local surrogate model, like I mentioned. So all in all, this code, it initializes the tabular explanation. Okay, this is unstructured data, and it's a classification model trained on tabular data, and it generates explanation for specific instance using lime, which provides local interpretable explanations for individual predictions by the model. Now let's go and print here lime explanation dot show in notebook. Let's print this. Now look at this beauty. What do we get here? This is obviously is what we are looking for. This lime explanation is an object that holds the explanation for this generated generated lime for specific instance. Show in notebook method is called on this object to display the explanation within the Jupyter notebook environment. Assuming that we are working in this specific environment, so I'm going to show in notebook. Since this in a section, it's for a representation purpose. I have shown here. Now look at this carefully. I can see the prediction probabilities. For this, I've given 0.96 as the prediction. I'm predicting that this record, if I'm going to do the random forest regress classifier, 96% I'm confident that it is setosa. How do I say that? How do I say that is the beauty here? Not versicolor, not versicolor, which is a contributing factor. It is not versicolor because it is of a petal length within so and so length. It is not versicolor because petal width is between so and so length. It is versicolor. I've given 0.04. It is versicolor because it is between so and so. Right. So what is the driving factor? The sepal length is one driving factor that is showing for versicolor. And we can see the petal length is 1.20, petal length is 0.2. So these are the possible explanations why we have given the probabilities 0.96 for cytosol. Okay, so this is the beauty here. Let's also display each feature's contributions. If I'm going to run this, I'm going to say petal length is less than less than equal to 0.160, and petal width, what is the sepal width, what is the contributions that is given from each and every features, right? So if it is less than equal to 1.60, there is a representation, there is a pattern understanding for this specific data set. So based on this understanding, some calculations, we are giving in local surrogate model and predict what is what. Let's give one here and see. And we can see that this is versicolor and what is not a versicolor. This versicolor, it is contributing to versicolor because of so and so reason. It's a local surrogate model. It can do wonders when I'm going to do it in a large scale data. This is the exact reason what we want to do using the Sharp and Lime models. Thank you. Hi. So in the previous session, so you have seen the various exploratory data analysis techniques. Now let's get started with the basics of machine learning. Let's get started. What is unsupervised versus unsupervised learning? So supervised learning, and classic example of unsupervised learning is a regression, right? So, and even before we get into various different examples, let's understand the definition. Supervised learning is a type of machine learning where the model is trained on a labeled data set, meaning each input is associated with a corresponding output. Say, for example, I'm going to predict whether a person will get a heart disease or not, given various different attributes, whether he's a smoker, alcoholic, what is his cholesterol level, what is his BP, systolic and diastolic, and what is his lifestyle. I have all these attributes. Given this attribute, I'm going to predict whether this person will have a heart disease or not. I'm going to train a model with a known labeled data. I'm going to have a model that's trained with the known labeled data. So unsupervised learning. So unsupervised learning is a type of machine learning where the model is trained on unlabeled data set. Okay, here it's a labeled data set. Here it's an unlabeled data set. I don't have a predefined label here. Say, for example, I have hundreds of photos and I'm going to, cluster or group similar person's photo. Is an example of an unsupervised learning. In supervised, again, it's of two different types, regression and classification. Say the classic example is your regression. We can predict in continuous values. Classification is whether an yes or a known, or whether it is a red color car, or it's a black car, or it's a white color car. So I'm doing a classification based on different categories. Regression is in continuous numbers, continuous values. For instance, we could predict the house prices based on features like size, location, and various different attributes. What is the price of that house given these attributes? For example, of a classification, we can assign inputs to predefined categories. We could identify and spam email based on their content on the metadata. Okay, in clustering, it's a common example of an unsupervised learning, where we can group similar data points together based on their features. For instance, we could group customers based on their purchasing behavior to identify the distinct segments. Another example is dimensionality reduction, where we simplify the high dimension data for visualization or analysis uncovering the hidden structures. So the key differences here, okay, between the supervised and unsupervised learning boil down to the availability of the labeled data and the learning objective. So in real world, most of the data that we receive is an unlabeled data set. In the journey of machine learning, it's going to be in the process of going from unsupervised learning to unsupervised learning. We have a data, we are going to cluster it, and we are going to label cluster A is a high valued customer, cluster B is a brand conscious customer, cluster C is irrelevant customer. So I'm going to cluster and I'm going to name it. So then the moment I name it, it becomes an labeled data set. Once the labeling is done, when there is a new data that's coming in, I'll be able to classify from either of these three classes, whether you belong to class A, B, or C. So like I mentioned, supervised learning requires an labeled data for training, aiming to learn, mapping from inputs to outputs. On the other hand, unsupervised learning works with unlabeled data, aiming to discover underlying patterns or structures in the data. So let's consider a practical application of both the paradigms. In supervised learning, we could predict the house prices based on historical sales data, leveraging the labeled examples. In the unsupervised, we could identify the customer segments based on the purchase history, uncovering hidden patterns without any explicit labels. So the process here is going to be the model learns from labeled examples provided during training. It generalizes from the training data to make predictions or decisions on a new or unseen data. So unsupervised learning, the model discovers patterns or structure in the data without explicit guidance. That's the important point. It seeks to find intrinsic relationships or representations within the dataset. So the application example is like predicting the house price based on the historical sales, identify the customer segments based on the purchase history. Now that we have known about what is an supervised, what is an unsupervised, now let's get into an overview of different machine learning algorithms. The often used in the industry machine learning algorithms, and the right way to put it, for the session. Now there are hundreds and hundreds of algorithms, right? So you write your own mathematical model, it becomes your own algorithm, right? So there are various different ML algorithms that we are that's available. Now the machine learning algorithms are the foundation of the predictive modeling and data analysis. They enable computers to learn from data and make predictions or decisions based on that learning. The number one, regression algorithms. What is a regression algorithm? So it's used to predict the continuous values. It's used to predict the continuous values based on the input features. So they model the relationship between the independent variables and dependent variables. So in the regression algorithm, there are various different types: linear regression and polynomial regression, a ridge regression, lasso regression, support vector regression, decision tree regression. So what is a linear regression? So the linear regression is basic and commonly used type of predictive analysis. It models the relationship between a dependent variable and one or more independent variables by fitting a linear equation to observed data. Let's take an industry example, predicting the sales revenue based on advertising spent across different marketing channels such as TV, radio, and online. Polynomial regression. The polynomial regression is in form of a linear regression in which the relationship between the independent variable and the dependent variable is modeled, as an nth degree polynomial. Predicting the performance of manufacturing process based on various factors such as temperature, pressure, and time is an example of a polynomial regression. Ridge regression. Ridge regression is a regularized version of linear regression that adds a penalty term to the least squares objective to prevent overfitting. Predicting house prices in a city based on features such as square footage, the number of bedrooms, and location while mitigating the impact of multicollinearity among predictors. Lasso regression. Lasso regression or the least absolute shrinkage and selection operator. That's what you call it as in lasso. L, least, A for absolute, S for shrinkage, another S for your selection, and O for operator, is another regularized version of linear regression that adds a penalty term lambda to the absolute value of the coefficients. So the industry example would be, predicting the customer churn in a subscription-based service by analyzing various customer attributes and behaviors. Your support vector regression. The SVR is a regression technique that uses support vector machines, SVMs, to model the relationship between the input variable and the target variable. The industry examples would be you're predicting your stock prices based on the historical market data, such as your trading volume, price trends, and economic indicators. Decision tree regression. Decision tree regression uses decision trees as a predictive model to map features to target values. It breaks down a dataset into smaller subsets while simultaneously constructing a tree-like structure. The industry examples for this would be predicting the risk of a loan default based on a borrower's credit history, income, and another financial attributes. Now, these are examples of your regression algorithms and their applications across different industries. So each algorithm has its strengths and weaknesses, and the choice of algorithm depends on the specific characteristics of the dataset and the nature of the prediction task. Now let's understand about the classification algorithms. So what is a classification algorithm? So classification algorithms are used to predict the categorical labels and classes of new data points. They assign input data to predefined categories based on their features. So like I mentioned earlier, classifying emails as spam or ham based on the content and the metadata. Now here for the classification algorithm, I've given you 6 different examples. Logistic regression, support vector machines, random forest, KNN, K nearest neighbors, decision trees, and naive Bayes. Now, what is a logistic regression? Logistic regression is a linear model used for binary classification tasks. It models a probability that is given input belongs to a particular class. In industry examples would be predicting whether a customer will churn or not based on their usage patterns and demographic informations in the telecommunication industry. Now let's take about your support vector machines. Support vector machines it constructs a hyperplane or a set of hyperplanes in a high dimensional space to separate the different classes with the largest possible margin. Like we can take the same example, the email messages spam or ham. I could use SVM to do the classification. Your random forest. Random forest is an ensemble learning method. Now, what's an ensemble learning? It's a multiple models together, multiple singular models combined, and I'm going to use it in an algorithm is called as an ensemble learning method that builds multiple decision trees and combines their predictions through averaging or voting. Few industry examples would be like predicting whether a loan applicant is likely to default or not based on various financial attributes in the banking sector. Now KNN, K nearest neighbors. KNN is a simple algorithm that stores all the available cases and classifies new case based on a similarity measure such as a distance. Few examples, some industry examples for KNN, predicting the sentiment of a product review as positive or negative based on similar reviews in sentiment analysis applications for e-commerce. Decision tree. The decision tree partitions the feature space into regions and make predictions by assigning the most frequent class labels of the training instances in each and every region. Classifying the customer segments based on their purchase history and demographic information for targeted marketing campaigns in retail. Naive Bayes. Naive Bayes is a probabilistic classifier based on the Bayes theorem with the assumption of independence between the features. The industry example is categorizing the news articles into different topics such as sports, politics, and entertainment. In news categorization systems. We can add up various different models like gradient boosting missions, GBMs. The gradient boosting missions is again an ensemble of weak learners. Subsequently, where each and every weak learner, new learner correcting errors made by the previous ones. Right. So these are few examples of classification algorithms and application across different categories and industries. Each algorithm has its own strengths and weaknesses. And the choice of algorithm depends on factors such as the nature of the data, problem domain, and computational resource available. That's the most important thing. Depending on the data that I'm going to use, right, the size of the data, the quality of the data, the selection of the algorithm depends on it. If I'm going to take an ensemble technique like random forest or gradient boosting, it's in multiple singular models that's been used here. That means there are multiple decision trees that's used to build a single model. So selection of this model is very important depending on the problem domain and the computational resources available. Thank you.
Hi folks, welcome back. So now let's see what is the importance of data cleaning. So we have seen data cleaning is a fundamental process in the data analytics journey. So playing a crucial role in ensuring the quality, accuracy, and reliability of data used for analysis. So let's explore why data cleaning is essential and how it enhances the accuracy of analysis results. Now, ensuring data quality. It's one of the primary reasons why data quality is essential is its role in ensuring data quality. So in today's data-driven world, organizations rely heavily on data to make informed decisions and gain insights into various aspects of their operations. Now, the problem here is the raw data collected from different sources often contains various errors, inconsistencies, inaccuracies that can compromise the integrity of analysis results. So by performing data cleaning, organizations can identify and correct these issues and thereby improving the overall quality of the data. This involves processes such as removing duplicate records, standardizing the formats, and validating data against predefined criteria. By enhancing the data quality, organizations can have greater confidence in the accuracy and reliability of their analysis results, which could lead to more informed decision making. So enhancing analysis accuracy. So another key benefit of data cleaning is its ability to enhance the accuracy of analysis results. So clean data leads to more accurate analysis and insights by minimizing biases and distortions that can arise from errors and inconsistencies in the data. Let's take, for example, what happens if there is an outlier or extreme values in the data. So these outliers or extreme values can skew the analysis results and can lead to misleading conclusions. So by identifying and removing outliers through data cleaning, organizations can ensure that their analysis reflects the underlying patterns and trends in the data more effectively. So similarly, handling machine values, standardizing data formats are essential steps in data cleaning that contribute to the analysis accuracy. So what happens if there is a missing value? So this missing value can introduce some uncertainty in the analysis results, so which could affect the reliability of insights derived from the data. Let's take, for example, in linear regression. There are few missing values in few of the columns, and rest all values are present in other columns. When I'm going to do a linear regression, by default, that row is omitted from the analysis. Even though we have collected and quality data, so that record is not considered for the analysis. So doing a missing value treatment is very important in various different ML models. By applying appropriate techniques such as imputation or deletion to handling missing values, so organizations can mitigate these uncertainties and improve the accuracy of the analysis. The last point which I want to discuss here is standardizing. So I want to standardize these data formats, ensuring consistency and comparability across different data sets, enabling a meaningful comparison and analysis. So what is standardization? So by standardizing formats, organizations can eliminate the discrepancy and ensure that the data from disparate sources can be integrated and analyzed effectively. So what happens? So this enhances the accuracy and reliability of analysis results by ensuring that data is consistent and comparable across the board. So the data cleaning is a crucial step in data analytics process, which ensures the quality, accuracy, and reliability of data used for analysis. So by identifying and correcting errors, inconsistencies, and inaccuracies in data, the organizations can improve the integrity of their analysis results and make more informed decisions. Now let's see what are the common data cleaning tasks. So as we have seen earlier, so why data cleaning is a crucial step, how it is important in preparing the raw data for analysis by identifying and correcting errors, inconsistencies, and inaccuracies. 3 points that I constantly repeat: correcting errors, inconsistencies, and inaccuracies. So let's explore some of the common data cleaning tasks and their importance in ensuring the integrity and reliability of the analysis results. The first important point is removing duplicates. So the duplicate records can significantly impact the analysis by skewing the data and leading to the inaccuracies in insights derived from it. So data cleaning involves identifying and removing duplicate entries from dataset to ensure integrity of the data. By removing these duplicates, organizations can improve the accuracy of their analysis results and can make more informed decisions based on the reliable insights. The second point here is handling the missing value. So missing values are a common occurrence in datasets and can adversely affect analysis outcomes if not handled properly. So data cleaning techniques such as imputation or deletion are used to handle missing values appropriately. Imputation involves replacing missing values with estimated values based on statistical methods or data patterns, while deletion involves removing records with missing value. Removing this record altogether. So by handling missing values effectively, organizations can mitigate the impact of analysis results and ensures the reliability of insights derived from it. And the fourth important point here is, the third important point here is the standardizing formats. So the data may be stored in different formats across different data sets. That makes it challenging to analyze and integrate data from disparate sources. So data cleaning involves standardizing formats to ensure consistency and compatibility across datasets. By standardizing these formats, organizations can eliminate discrepancies and ensure that data can be integrated and analyzed effectively. So this enhances the reliability and usability of the data for analysis, which enables the organization to derive meaningful insights and make more informed decisions based on the consistent data. The fourth important point which I want to pick up here is correcting the inaccuracies. So the inaccurate data, such as incorrect values or typos, can distort the analysis results and lead to misleading conclusions. Data cleaning techniques such as validation rules and outlier detections are used to identify and correct inaccuracies in the data. Validation rules are applied to ensure that data meets predefined criteria or business rules. While this outlier detection technique identify and remove data points that deviate significantly from the norm. Therefore, by correcting inaccuracies, organizations can improve the accuracy and reliability of their analysis results, which can enable a more informed decision making based on the reliable insights. So, I would like to conclude, this common data cleaning tasks, such as removing duplicates, handling missing values, standardizing formats, and correcting inaccuracies. These are essential for ensuring the data integrity and reliability of data used for analysis. Therefore, by performing this task effectively, organizations can improve the accuracy for their analysis results and make more informed decisions based on reliable insights. Data cleaning plays a crucial role in the data analytics process, enabling organizations to unlock the full potential of their data, which can drive business success in today's data-driven. Now, what are the different data cleaning processes? Now, out of many, I have taken 4 important data cleaning processes. So, the data cleaning process, that, like we have seen, is a crucial step in the data analytics journey that involves preparing raw data for analysis by identifying and correcting errors, inconsistencies, and inaccuracies. Let's explore the different steps. Let's start with the data assessment. So the first step in the data cleaning process is data assessment. So this data assessment involves conducting a thorough evaluation of raw data to identify quality issues, inconsistencies, and errors. Therefore, during this stage, data analysts examine the data closely to understand the structure, format, and content. So, they may use some techniques like data profiling and exploratory data analysis to uncover potential issues. So, in later part of this session, we'll also see, let's take a data set and do an exploratory data analysis, and let's do all the data cleaning process that we have discussed so far. So by conducting a comprehensive data assessment, organizations can gain insights into quality of their data and identify areas that require attention during the cleaning. Data validation. So once data quality issues are identified during the assessment phase, the next step is the data validation. Data validation techniques are used to verify the accuracy and integrity of the data and ensure that it meets predefined quality standards. So what does it? So this involves performing checks and validations to ensure that the data conforms to expected patterns, rules, and constraints. Let's take an example for data may be validated against a predefined business rule. The data integrity constraints or statistical criteria. So by validating the data, organizations can detect correct values, inconsistencies, and inaccuracies early in the process, preventing them from propagating through the subsequent analysis steps. So what is an data transformation? So once the data has been assessed, data is validated. So what is data transformation? So the data transformation here, what I mentioned, is normalization, scaling, and feature engineering. So we have an original set of data, age, salary, years of experience, what is the color of, what car does this customer hold. I'm going to have all this data. It could be numerical, categorical, nominal, ordinal, a ratio, any kind of data. So after validation, so the data undergoes a transformation to prepare it for the analysis. Therefore, the data transformation involves applying various techniques like the normalization, scaling, feature engineering, to enhance the quality and usability of the data. So what is the need of a normalization? So the normalization involves standardizing the data values to a common scale or in range, so that all the values in the data set are between and range. Say for example, age, salary, years of experience, this all has different units. If I'm going to standardize this data, all these values will be between the range of -1 to +1. So which can make it easier to compare and analyze different, across different variables. Scaling adjusts the magnitude of data values to improve model performance and convergence during analysis. Feature engineering involves creating new features or variables from existing data, to capture relevant information and improve predictive performance. Therefore, by transforming the data, organizations can ensure that it is suitable format for analysis and it contains meaningful features for deriving insights. So what is data cleansing? So once I have done the transformation, the data cleansing involves correcting errors by removing duplicates, resolving inconsistencies to ensure the integrity of the data. Right? So it involves tasks such as deduplication, where the duplicate records are identified and removed. Error correction, where inaccuracies in data are corrected or imputed. Data cleansing also involves addressing missing values, outliers, and other anomalies, which may affect the analysis outcomes. Therefore, by performing thorough data cleansing, organizations can ensure that the data used for analysis is accurate, reliable, and fit for purpose, enabling more informed decisions based on reliable insights. So, the data cleaning process is a critical step in data analytics journey, which ensures the integrity and reliability of the data used for analysis. By following a structured approach that includes data assessment, validation, transforming, and cleansing, organizations can prepare their data effectively and derive meaningful insights that drive informed decision making. Data cleaning plays a crucial role in unlocking the full potential of data and enabling organizations to gain actionable insights and achieve their business objectives in today's data-driven.
Welcome back, folks. So in the previous few sessions, we have seen about supervised versus unsupervised learning. What are the different machine learning algorithms? What are the different exploratory data analysis techniques? And we were comparing various different algorithms, model bias and limitations. And what are the different types of bias? Now, in this session, let's take a small example about the exploratory data analysis and explain, and let's take a data set and understand what are the different steps involved in an exploratory data analysis. So the first step in doing the exploratory data analysis is importing the necessary libraries. I'm under the assumption you have installed the Python and Jupyter notebook and you have the notebook ready. Okay, I'll share you this notebook so that you can also try it along. So the first step here is going to be importing the necessary libraries. So the libraries that I'm going to use are pandas, numpy, matplotlib for visualization, seaborn for visualization. For pre-processing from scikit-learn, I've taken the standard scalar, and from scikit-learn decomposition, I've taken the principal component analysis for orthogonal rotation and dimensionality reduction. Now let's take the famous example dataset, iris dataset. I'm going to take it from Seaborn. SNS is the alias name. SNS dot load dataset. I'm going to take iris, IRIS. I'm going to save it inside the object name, iris. Okay, I have to run this libraries. Now let's display the first few rows of the dataset. I have the dataset. Now how will I make sure how the dataset is? How is it structured? I'm going to use iris.head.
Iris.head will give me the first 5 rows in the data. You can argue that why is it till 4? The indexing in Python starts from 0. Therefore, 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4. So, first 5 rows with the index starting from 0 is what is shown here. Let me put that inside in print command. Print iris. And let's also give a reference name. Print head of the data set as, okay, head of the data set as, okay. So it's printing here head of the data set, and we have sepal length, sepal width, petal length, petal width. So these are the different columns that I have, and I have the species. Okay, what all different species that I have here? Iris, species dot unique. Okay, so I have 3 different species: Tetausa, versicolor, virginica. Okay, for these 3 different species, I have sepal length, sepal width, petal length, petal width. Unique will give me what are the different unique. It will remove the duplicates and it will show us what are the different unique elements that's present in that specific column species. To take one specific column, I have to give the name of the dataset and put it in a square bracket and specify the column name in single or in double quotes. Next is the summary statistics. Now I need to understand how is that the data is distributed. What is the summary statistics here? So first let me print summary statistics. This is an escape sequence. Summary statistics, and I'm going to print iris dot describe. Okay, let me also put here an escape sequence to start it in a new line. Okay, so there is enough space here. Okay, so summary statistics. So for sepal length, okay, the median sepal length is 5.8 units. Sepal width, the median is 3 units. Petal length is 4.35 and petal width is 1.3. So this is what we see in summary statistics. So when I give describe by default, all the numerical attributes are taken or considered, and it gives me the famous 5-point summary. What is the 5-point summary? Min, first quartile, second quartile, third quartile, max. So this is what you call it as a 5-point summary. On top of that, I get the count. So how many rows are present in the sepal length? 150 elements are present. So mean, the average for sepal length is what? The mean, the average of sepal width is what? Okay, the petal length is what? Petal width is what? So, and I also have the standard deviation. So you can see that the standard deviation for sepal length is 0.82, which is relatively less in comparison to the petal width, which is 1.76. So these are some understandings that I get once I get the data set. So this is the number one thing to do once I have the data in hand. Now let's also start with some visualization techniques. The famous visualization technique is your pair plot. So what does a pair plot do? Pair plot is used to visualize the relationship between the variables and among that variables itself. So what does it mean? SNS dot pair plot. You give the name of the data set, iris, comma, hue. What does a hue mean? So I'm going to differentiate different species. I'm going to take a differentiating element which could differentiate the different the elements that's present in this data set. So I'm going to differentiate with species, and I'm going to give different markers here. Markers as O, S, and D. Okay, and then let's add a title pair plot of iris data set. Okay, and then you put plt dot show, and then you get your famous pair plot. So you can see here there are three different species that's present: Setosa, Versinica, Versicolor, Virginica. Okay, how are these three species differentiated with respect to sepal length, with respect to petal length, with respect to sepal width and petal width? So that's what and pair plot is helping us to do. So what does the sepal length versus sepal length mean? That means I'm going to take all the elements in sepal length and I'm going to plot with respect to different species: Setosa, Versicolor, Virginica. So the blue color, so that's what I have given three different markers. The circle, a square and diamond. Okay, with respect to three different species, the legends. So how is it distributed? Right. So you can see that the distribution of Setosa is higher, right? So the highest point is comparatively higher in comparison to versicolor and virginica. Okay, that's a very important observation that we need to have. Okay, and comparatively, what is the sepal length, what is the sepal width, and you can also compare sepal length and sepal width. Okay, and scatter plot among three different species. So this gives a very interesting observation when I'm having a data set to do the classification kind of a modeling. What is an important attribute which could classify a class as a class? What does it mean? If there is a very clear separation, say this petal length, just by this petal length, I can clearly distinguish Setosa in comparison to versicolor and virginica. Just by taking this petal width, I can distinguish the Setosa in comparison to versicolor and virginica because it's completely different. The length, the width is completely different in comparison to the the versicolor and virginica. This is the beauty of a pair plot. Okay, so what is that one distinguishing attribute which can classify the data in a right manner? So that's the beauty of the pair plot. So the diagonals or the distribution of itself, the off diagonal elements or the scatter plots. Okay, so I'm comparing one element to the other, one attribute to the another attribute. Given different hues, what is an hues? Given different species, how does it perform? Now let's remove this hue. So you'll have a flavor. How does this pair plot look like? Now you can see, now without and bringing in an element of hue, how does it differentiate between the different elements? Okay, so the petal length and petal width are linearly correlated. As petal length increases, your petal width increases. As your petal width increases, your petal length increases. So this is a very important observation that we can see. Now you can see here sepal length and petal length, one increases, another also increases, leaving out few different data points. Now let's bring in hue here to understand, is it with respect to one species, is that happening? That's perfectly right. So leaving around the Setosa, for the other two species, versicolor and virginica, as the petal length increases, your sepal length increases. However, for Setosa, it is not. So this is clearly different in comparison to versicolor and virginica. So these are some various different observations that I can find using a pair plot. Now let's take a box plot. Let's use SNS.boxplot. SNS.boxplot data is equal to iris, and let's use plt dot figure fig size is equal to 10,6. Okay, I'm making the size relatively bigger so that we can see. Plt dot title box plot of iris data set. Okay, and I'm also giving plt dot show. Okay, now we can see the box plot of the various different elements, the different attributes: sepal length, petal length, petal width, and sepal width. Okay. Now pause for a moment. Think which attribute has an outlier here and why. You can see clearly that sepal length has an outlier in comparison to sepal length, petal length, and petal width. So this is given by the small circles here. So this has an outlier. Okay. Now how do you find missing values? Is there any missing values in the data set or not? Let's print iris dot is null dot sum. Print missing value analysis. Okay. Now the missing, so the command here is null. Is null is an function. Okay. So and I'm summing up all the missing values in different attributes. So I don't have any missing values in the attributes that I have taken. If there are some missing values, it will show the count, right? Because is null is a Boolean outcome, yes or no, right? So Boolean is always associated with yes is equal to 1, no means 0. So if I sum up all the yes, it will show the count of the missing values that's present in that attribute. Now let's go to correlation. So what's in correlation? Now I need to take the different attributes iris dot cor. Okay, let me save it inside cor is equal to. Okay, now let us take SNS dot heat map. Okay, cor comma annotation is equal to true. Okay, I'm sorry, I don't have to give this in quotes. Annotation is equal to true, and then I'm giving some color map is equal to cool warm. Okay, and then I can also add line width is equal to 0.5. Okay, run this. Okay, all right. So now let's add the column names. The sepal length, sepal width. So which are all the numerical attributes. Now if I run it, I can get rid of it. Get rid of that error. plt.show will get rid of the unwanted the write up, and it will give plot as the right plot. Okay, so as it is closer to 1, it's highly correlated, right? So as it's close to blue color, it's negatively correlated. The correlation coefficient is always between the values of -1 to +1. So this color indicates whether it is positively correlated or negatively correlated. Now let's standardize this feature. So how will I standardize this feature? So I'm going to make use of an standard scalar. Standard scalar as a function, and scalar is equal to. Okay. Now how will I do it? Scalar dot fit transform iris dot loc ilog. Okay, comma to -1. Okay, now I call it as scaled features. Okay, now let's print the scaled features. Okay, now you can say, so what does then scaling mean? So we know that the scaling happens. I'm going to take the value, subtracted with the mean divided by the standard deviation. It will give me the scaled values. I'm going to standardize these features so that the different unit, the sepal length, sepal width, petal length, petal width, it could be of different units. I can bring that all to a similar unit, and I can apply a dimensionality reduction technique such as PCA. Right, PCA does an orthogonal rotation so that I could reduce the components to fewer components. So that 4 components, I aspire to reduce it to 2 different components. Now let's see. Now PCA dot fit underscore transform. Okay, of the scaled features. These are the principal components. I'm calling this P underscore C. Okay. Now let's run it, and then let's convert it to a data frame. Data frame of the data is equal to principal components, comma, the columns is equal to, let's call it as PC1, comma, PC2. Okay. And then I'm going to call it as principal df. Okay. Now let's concatenate pd dot concat, and I'll show you the principal df, comma, iris species in an axis is equal to 1. Okay. Now you can see the final data frame is how it's going to look like this. Final df. Okay. So I'm going to take various different attributes like the iris dot head. I had 4 different attributes: sepal length, sepal width, petal length, petal width. I'm compressing it to 2 different attributes using a technique called as a principal component analysis. Okay, this is one of the technique. Okay, now let's do the scatter plot. SNS dot scatter plot. Okay, let's give x is equal to PC1 and y is equal to PC2, and let's give hue is equal to species, and the data is equal to final df. Okay. uh, okay, so yes, so I'm going to take 2 different principal components, PC1, PC2, and with different to species. You could, as we have seen earlier, Cetacea can be clearly seen aside comparison to versicolor and virginica. Okay, this is a simple exploratory data analysis where we have done n step of procedures. Thank you.
Hi folks, welcome back. So in this session, let's look at the best practices for data cleaning and data exploration and data analysis. So effective data cleaning is essential for ensuring accuracy, reliability, and usability of data for analysis. So by following best practices for the data cleaning, any organization can streamline the data cleaning process and maximize the value of the data assets. So in which I have taken 4 key steps here: defining the data quality metrics, and automate wherever it is possible, document the changes, iterate and validate. Now let's see what is defining in data quality metrics. So one of the foundational best practice for data cleaning is to establish some clear data quality metrics and standards. So this involves defining the criteria and benchmarks to assess the quality, accuracy, and completeness of the data. Quality, accuracy, and completeness. So by establishing the clear data quality metrics, organizations can guide the data cleaning process and ensure consistency and accuracy across datasets. For examples, data quality metrics may include measures such as the data completeness, accuracy, consistency, and timeliness. So by defining the data quality metrics upfront, organizations can set clear expectations for data cleanliness and monitor progress throughout the data cleaning process. The second important point that I want to bring up is automate wherever it is possible. So another important best practice of data cleaning is to leverage the automation tools and scripts to streamline the repetitive tasks and minimize the minimal effort. So automation can help to accelerate the data cleaning process, improve the efficiency by automating routine tasks such as data deduplication, error collection, outlier detection. So
if we start automating these repetitive tasks, organizations can free up valuable time and resources, allowing the data analyst to focus on more complex analysis tasks and strategic initiatives. Third important point is document change. So it is one of the least, a focused item. So it's essential to document all the changes made during the data cleaning process to maintain transparency and traceability. So this includes documenting the rationale behind each change, the methods used to clean the data, and any assumptions or decisions made during the process. So we'd have assumed something before making any analysis. So we have to put that assumption up front. So by documenting these changes, organizations can ensure data cleaning activities are transparent and reproducible, which can enable other stakeholders to understand and validate the results. This can overcome the dependency created. So documentation also facilitates collaboration and knowledge sharing among the team members, ensuring that everyone is aligned on the data cleaning process and its outcome. The fourth important point is iterate and validate. So the organization should iterate through the data cleaning process, validating changes and ensuring that the data quality standards are met. This involves conducting thorough validation checks to verify the accuracy, integrity, and completeness of the clean data. Iterative validation allows organizations to identify and address any remaining issues or discrepancies in data, ensuring that it meets the predefined quality standards before proceeding to analysis. So, what happens if I'm going to iterate? Right. So, if an organization follows this iterating and validation rules, it can have confidence in the quality and reliability of the data. Right. So, once the confidence has increased in the quality and reliability of the data, so which can enable to more accurate and meaningful analysis outcomes. So, the best practices for data cleaning are essential for maintaining the data quality, accuracy, and reliability. Three important points: data quality, accuracy, and reliability throughout the data analytics process. Right. So, where I'm going to leverage, automation tools, document changes, iterating, and the validation changes. Therefore, the organizations can ensure that the data is clean, consistent, and fit for its purpose. Data cleaning plays a crucial role or a critical role in unlocking the full potential of data and enabling organizations to derive meaningful insights that drive informed decision-making and business successes. Now, let's get into data exploration. So, the data exploration is the fundamental aspects of the data analytics process, which provides insights into the characteristics and patterns present within the dataset. So, it involves both visual and analytical methods to understand the underlying structure of the data. Therefore, by summarizing the key features, identifying the trends, and uncovering relationships, data exploration lays the groundwork for further analysis and decision making. So, the important point is EDA, exploratory data analysis. The core of data exploration lies in the exploratory data analysis, EDA, which we'll be covering in the forthcoming sessions. We'll take a case study and we'll do a step-by-step what happens in an exploratory data analysis. So, the EDA, the exploratory data analysis, is a critical step in understanding the distribution, relationships, and anomalies within the data. So, EDA techniques encompass a range of methods, including summary statistics, data visualization, and correlation analysis. Now, the key components of data exploration are the four different steps. It's three different steps: the descriptive statistics, data visualization, and correlation analysis. So what is descriptive statistics? So descriptive statistics provide a summary overview of key characteristics within the dataset. Take for an example, measure of central tendency, mean, median, mode is an example. And variance, standard deviation offer an insights on the variability, and skewness will help us to understand the distribution of the data. So by summarizing the statistics, analysts can quickly grasp essential aspects of the data set's distribution and variability. The second important point is data visualization. So the data visualization plays a pivotal role in data exploration, offering intuitive and insightful representations of the data. There are various different plots, out of which these 4 plots are very much important: histogram, scatter plots, box plot, and heat map. So I'm going to use this plot, which can help me to provide the visual cues about the distribution and relationship between the data. So through visual exploration, analysts can identify patterns, outliers, and trends that may not be apparent for a numerical summarism. The third important point is the correlation analysis. The correlation analysis delves into the relationship between the variables within the dataset. What is the correlation between variable A and variable B? What is the correlation between the years of experience and salary? What is the correlation between the number of cigarettes a person smoked and heart diseases? So correlation analysis delves into the relationship between the variables that I'm going to do the analysis. So by identifying the correlations, analysts can uncover a potential pattern or a trend and can gain insights into how variables interact with each other. So it's obvious, as the years of experience increases, the salary increases. So we know that these two variables are correlated. So the correlation did not directly equate to a causation. That's a different concept altogether. But the crux of a data exploration is the correlation. So the techniques such as correlation coefficients and scatter plots help to visualize the strength and direction of relationship, which can enable the analyst to discern meaningful associations within the. So this data exploration serves as a foundation step in the data analytic process, providing essential insights into the characteristics and patterns within the data set. So through techniques such as your descriptive statistics, your data visualization, and correlation analysis, any analyst gain a deeper understanding of the data's distribution, the relationship, anomalies that's present in the data. So by harnessing the power of data exploration, organization can uncover valuable insights, inform decision making, and drive innovation in the data driven. Now let's see what are the few benefits of data exploration. So the data exploration is a fundamental step in data analysis process that we have seen, so which offers some numeric benefits across industries. So let's explore some of the key advantages of data exploration and also take some industry examples. So what's identifying a pattern? So the data exploration helps to identify patterns, trends, and outliers in the data. The 3 important points that we are mentioning it again and again: identifying patterns, identifying trends, identifying outliers in the data, providing valuable insights for further analysis. Let's take a retail industry. So analyzing the sales data can reveal a seasonal trend, customer preferences, and product performance, helping retailers optimize inventory management and marketing strategies. Let's take a different example, healthcare industry. So by exploring the patient data, we can uncover patterns in the disease prevalence, treatment outcomes, and healthcare utilization, enabling the healthcare providers to improve the patient care and the resource allocation. So, let's get into the second aspect here, informing analysis technique. So, the insights gained from the data exploration inform the selection of appropriate analysis technique and models for a deeper analysis. Let's take two different examples in financial service industry and manufacturing industry. So if I go back to the financial service industry, if I take a financial transaction data, it can help the institution to identify the fraudulent patterns and develop a predictive model to detect the fraudulent activities, protecting customers and minimizing the financial losses. Manufacturing industry, it can help us, analyzing the production data and inform the selection of process optimization technique and predictive maintenance models, helping manufacturer improve the efficiency, reducing downtime and optimizing the resource utilization. The third important point is detecting anomalies. So exploration techniques can help in detect anomalies or irregularities in the data. Let's take examples of telecommunication and e-commerce. So exploring network traffic data can uncover, unusual patterns or let's take a spike in the usage. So indicating the potential network issues or security threats that need to be addressed. So e-commerce industry. So if I go through the transactional data, it can help us, reveal unusual purchasing behavior or fraudulent activities, prompting e-commerce companies to implement fraud detection measures and enhance the transaction security and protect the customers and maintain trust. So these are the crux, the benefits of the data exploration. Now, what are the key steps in data analysis? The key steps in data analysis are data pre-processing, exploratory data analysis, hypothesis testing, model building, and interpretation and reporting. So we have seen this again and again. The types of data analysis are descriptive analysis, diagnostic analysis, predictive, and prescriptive. So the key steps here would be these 5 different steps. So those are the 4 types of data analysis. These are the key steps in data analysis. So the data pre-processing help us to clean the data, transform the data, and format the data to ensure quality and consistency. Exploratory analysis we have seen earlier as well. It helps us to understand the data, characteristics, patterns, and uncover any relationships within it. So hypothesis testing, it involves in formulating and testing hypotheses to validate any assumptions that is there and theories about the data. There could be many tests like t-test, ANOVA, chi-square test, which can help us to understand whether our inline, the understanding is true or not. Model building. So what is model building? This involves in developing a mathematical or computational models to analyze the data and make predictions or recommendations. Like say some models like regression analysis, classification algorithm, clustering algorithm, and the neural networks help us to build the predictive models based on the interpretation and reporting. So the interpretation and reporting involve, interpreting analysis result, communicating finding to stakeholders through reports, visualizations, or presentations. This could include summarizing key findings, highlighting insights, and providing actionable recommendations based on the analysis results. Thank you. So in the previous session, we have seen about the different machine learning algorithms, starting from regression algorithms and its types, classification algorithms and its types, and clustering algorithm and its types. Now let's see in quick demo by taking a data set, and let's see what we can do with the various different machine learning algorithms. So let's start with importing the necessary libraries. So let's import NumPy, Pandas from scikit-learn, various different modules and scikit-learn data sets, and your model selection, linear model, ensemble, cluster, metrics, and pre-processing. And I've also suppressed the warnings that it's not required for us. Now let's also generate some random data for regression. Like I mentioned, regression happens when you have a continuous data points to be predicted. So I'm going to give numpy dot random dot seed. I'm giving in random seed, and pseudo random number generator. I'm just activating it. X regression np dot random rand, okay, 100 comma 3, okay, and y classification for the y regression, and I'm going to give np dot random dot rand. I'm generating 100 random numbers, okay. np dot random dot rand, okay. So sorry, typo. Now let's load the data set. Okay, for the classification, let's load the classic iris data set. Load iris, and I'll save it inside iris is equal to, and let's also take x classification is equal to iris data and y classification as iris target, okay. So I've taken the data for regression and for classification. Let's also take for clustering. I'm making some blobs. Make blobs n samples is equal to 300 comma centers is equal to 4, cluster std is equal to 0.6 and random state is equal to 0, okay. I'll put it inside x cluster comma and random variable. Now let's split the data into training and testing sets. Okay, so to make the data into training and testing, I'm going to use the module train test split from the scikit-learn model selection. So what does a train test split do? So it randomly splits and and it records into the corresponding variables x reg comma y reg, and I'm going to give test size is equal to 0.3. That means I'm going to split the data set into 70-30%. I'm considering 30% as the testing set and 70% for the development, okay. And I'm going to give random state is equal to 42, okay. And I'm going to save it inside variables x reg train comma x reg test comma y reg train comma y reg test, okay. So this should be the order: x reg train and x reg test, y reg train and y reg test. So what does it mean? It takes the x variable, y variable, splits it into 70-30% in a randomized order. I'm giving in random state is equal to 42. So if you are also going to give the 42, so the random split what I'm getting and you will be getting is the same. So the x classification train comma x classification test comma y classification train comma y classification test is equal to train test split, okay. And let's just copy paste the same and edit it inside it, okay. Now xreg, instead of xreg, what was the name that we used? X classification and y classification, okay. And I'm going to standardize this data for feature for clustering. So since clustering is a distance based measure, I'm rather going to standardize. Standardizing is very, very important when I'm going to do a clustering, okay, because it's a distance based measure. Whenever I'm going to use a distance based measure models, I need to standardize the data, standard scalar, okay. So I'll use a standard scalar and save it inside scalar is equal to Okay, X cluster scaled. Okay, whatever the data that I have taken, scalar dot fit transform. So what does the fit transform do? It applies the formula and transforms the original data set into the scaled variable. If I'm going to use the fit, it's going to calculate only the mean and the standard deviation, and it's going to save it in a separate attribute. If I'm going to put fit underscore transform, it's going to apply the formula, transform it, and save it inside this new variable X cluster scale. Okay, now let's put it inside X cluster. Therefore, I have X cluster scaled as a new data point for, okay, it's in small x for doing the clustering algorithm. Right, so in quick recap, so I am going to load all the libraries, and for the regression, I'm taking in random numbers. I'm calling it as X regression, Y regression as the target column. For the classification, we have seen the species as your Y target variable, and X is going to be your sepal length, sepal width, petal length, petal width. These are the 4 attributes that will be in your predictors, the X classification, X variables. For clustering, again, I'm taking samples, and and I'm calling it as an X cluster. Therefore, for training and testing, I'm going to use it for the regression and classification. I'm going to split it into 4 different attributes: xreg train, xreg test, yreg train, and yreg test. Similar note for the classification also. When I'm going to work with clustering, it's very important to scale it. Once the scaling is done, now let's go forward and build the linear regression models. So let me define that as linear regression models. If I'm going to have multiple models in place, how will I differentiate it? Linear regression, and put it as linear regression as in an bracket, and then say for example I want to use one more model here. Say for example I want to use an ensemble technique like random forest classifier, or random forest regression. The random forest regressor. You do it and you run this. Okay, now similarly for the classification models is equal to let's take the famous logistic regression in bracket, and then random forest classifier. Okay, random forest classifier, open close bracket, and okay, I forgot to given comma. Okay, now what I have done, I'm going to use for the regression models two different models: linear regression, random forest regression. On the similar note, for the classification models, I'm going to use logistic regression and random forest classifier. For the clustering models, I'm going to use an k-means algorithm. Class models is equal to, I'm going to have k means, and k means n underscore cluster is equal to 4. Okay, I'm going to have okay, n underscore, okay, it's n underscore clusters. Okay, n underscore clusters. I'm going to have 4 different clusters for the k-means algorithm to run. Now let's train and evaluate the regression models. Now I'm going to run it in a loop. For name comma model in the regression models dot items, the classic way of running it, model dot fit, okay, x rig train comma y rig, let's go back, better to copy paste, x rig train and y rig train, Okay, and then the model is fit, and then what you do, I predict it. Y pred is equal to model dot predict, right? So what do I predict? The test x reg test. Okay, the test is the one that I need to predict. For that, I need to have a metric to validate. I'm going to have a mean squared error. I'm going to have a mean squared error as a metric. I'm going to compare between y reg, the actual, comma, the predicted, y pred. Okay, so once I'm predicting it, I'm going to print it. Print what I'm going to print the name and the accuracy. Okay, accuracy as accuracy. Okay, and close the bracket. Now you run it. Okay, now yeah, so it's going to be MSE, right? Mean squared error. It's a regression model. Okay, now the model is run and it shows the mean squared error for a linear regression is 0.09. However, for a random forest, it's 0.10. Right, so on similar note, I'm going to do the same for a classification. Okay, so what should I make the changes? It's all the classification models. Okay, now x reg, instead of that, I'm going to take x classification train and y classification train, y classification test. Okay, so y classification test, y predict. So here, since there's a classification, I'm going to take a metrics as accuracy. Accuracy as a metric. I'm going to take it. Now this MSE won't come. So what will happen here? Accuracy score. Accuracy score between Y classification test and Y pred. So this is the accuracy. Okay. Now you run this. Perfect. Now it's showing as 1. So whenever it is 1, so we need to go back and double check whether it's not an overfit, and we'll have to do it. Since it's just the basic way of running it, I'm just showcasing how we can run an random forest regressor, random forest classifier, and the basic models and overview. Right now, yeah, so this is for the classification models. So this should come here ideally. And yeah, now let's try and visualize the clustering model. Now we have done for the regression and classification. Now for the k-means, I'm going to take n clusters is equal to 4. I'm going to take n init is equal to 10. Okay, and let's say k-means is equal to so and so. Okay, now I'm going to say k-means dot fit. Okay, x cluster. I need to take the scaled one, right? What was the name of it? So if I go back again, yeah, x cluster scaled, because these are all distance based measures. I need to scale the data point that I've mentioned earlier, and I'm going to put the the other attributes like PLT figure and scatterplot of the k-means clusters. The title is k-means clustering with the different features that I'm going to run. Okay, so you can clearly see that I have 4 different clusters, since I have given n clusters as 4. Okay, so n clusters. So this is the centroid that's shown here. So it's going to iterate and it's going to find the centroid of the features. This is how one basic clustering is done. Okay, thank you.